Hi, my name is Noah Rose, and this is my an analysis of the English Premier League dataset. Going into the dataset, each row was a summary of a single English Premier League game from a single team's perspective. Among the stats that you will find is H underscore A, which is whether they're home or away, XG, which is expected goals scored, which is actual goals scored, PPDA versus deep, which is the amount of defense versus offense they spent, shots on target, fouls are all pretty self explanatory. Our first question is whether we can cluster these based on variables such as PPDA, deep, and shots. We ended up just using deep, PPDA, and shots instead of the other ones. We used the GMM model. Uh, just thought this was the best way to cluster these between offense, defense, and average, and you'll see it going forward. Deep play being offensive, shots also being offensive. This was a pretty linear relationship between the two, which makes sense. Purple being offensive, green being average, yellow being low. You'll see this again in this one, where the shots were obviously offensive teams, purple being at the highest, yellow being defensive teams, and this last one was sort of the best, where we saw deep play versus pressing play, sort of the tightest clusters, and I'd probably use this one going forward to look at teams for oncoming games and try and categorize them. But again, pretty obvious purple highest offensive teams, yellow highest defensive teams, and green sort of somewhere in between, or one of the extremes that didn't maybe have as good of a game that game. So going on to the second question, the most important differences between playing at home versus playing away. This is one that I really wanted to look into because people always say that home is an advantage, but I wanted to check it. These are the two data sets, home being the top, away being the bottom. We're going to kind of get into the differences between them going forward. I just wanted to put all the data out here so you can look more into it. Offensive stats was an important thing here. Deep, the time they spent on offense, and shots was higher on average for home teams versus away teams, which is good. You want to spend more time on offense, so it kind of furthers that point that home teams have an advantage. This is furthered by the defensive stats, which are higher for away teams. The pressing play and the fouls, which are usually on defense, were higher for away teams, pretty similarly to the advantage that the home teams had on offense. So that makes sense. They're pretty inverse. Then we can look at the expected results. I thought this was really interesting. The home teams were expected to score more goals and expected to win more often than the away team, and win by a significant amount, actually, considering it's only 0 for a loss, 1 for a draw, and 3 for a win. That difference in the average is pretty high since they're usually around 1.5 ish. And so I thought that kind of proved that the people always expect that home teams to win, and I wanted to really check that. So I looked at the sum of the results, and on the left you can see the home team wins significantly more than the away team wins. Obviously, they're inverse. If the home team wins, the away team loses. But I thought that was a really cool difference to see there, and kind of proves the point that home teams do have an advantage and usually win more often than home teams win more often than the away teams. So going into our last question, can we use the continuous variables that we have available to us to predict wins? And is the accuracy high enough to influence sports betting, which is a higher than like a 0.5? We realized, long story short, this is not true. These models weren't very good. I tried using logistic regression to pick out wins, draws, or losses, and obviously did not do very well. Actually had a negative R squared. And so I tried to use Lasso, and it worked. It made it better. I got to like a 0.3 R squared, which is pretty decent, but still not above that 0.5 threshold that we were looking for. But it's a little more interpretable than the logistic regression was. Looking at the coefficients, OT ratio, which is the shots to shots on target ratio, was the highest magnitude, followed by shots. Makes sense. The more you shoot, the more you're going to score, the more you're going to win. So yeah, conclusion overall, we found that there's a pretty accurate, distinguishable difference between offensive, defensive, and average teams using shots and deep and PPDA and those three variables. We found that there was a distinct difference between home and away teams. Most importantly, that home teams have a higher success rate, more likely to win, actually supported by the data. And for the last one, we learned that the variables we have aren't very good at predicting which team won, tied, or lost. But the Lasso was sort of able to improve the model, even though it wasn't by very much. It still didn't break that threshold. So yeah, thank you so much. I hope you enjoyed the presentation, and have a great day.